What type of bond is present in the molecular compound H2O, which is water? Is it a polar covalent bond? Is it a metallic bond? Is it a nonpolar covalent? Or is it ionic? Well, great question. Let's get down into it. So we definitely have water, right? So maybe I'll say, okay, we have hydrogen, we have two of them, and we have an oxygen. And we know that we are going to be having bonds in here. Now, in order to figure this out, we have to figure out what is the bond that's in H2O, right? Now, keep in mind that hydrogen is the most simplified element. Hydrogen has an atomic number of 1. So, hydrogen only has 1 electron. So, it could only form 1 additional pair, right? And it's also great to know what hydrogen is. Hydrogen is a nonmetal. It's the only nonmetal that is on the left side of the periodic table. Oxygen is on the right side of the periodic table, and that is also a nonmetal. So we have two nonmetals coming together. That could simplify some things for us, right? We have no metals here. Hydrogen's a nonmetal and oxygen is a nonmetal. So I can't have any bonds that have to do with metals. So literally, metallic, absolutely not. This can't even be. We have to have a metal here. It is a metallic bond. So that's out. Another answer is ionic. That's out as well, because ionic, the general consensus of ionic is a metal and a nonmetal. Since we have no metal, can't really be ionic. But now we're down to polar or nonpolar covalent. And covalent bond is the bond between two nonmetals. So we got that far. Nonmetal plus another nonmetal. Okay. So now we know that we're going to be bonding between a oxygen and a hydrogen. And just know that you don't need to know whether it's a single bond, a double bond, a triple bond. It doesn't matter for that. The only thing that we have to know is we know that we have at least one bond between the oxygen and the hydrogen, right? In this case, there's 2. But we only care about, one of them because each of these bonds are the same, right? And for this question, we don't care about lone pairs or anything like that. You can write out the correct Lewis structure, but you don't have to. If you want the correct Lewis structure, it would be 2 lone electrons, and that's because of the octet rule. But we are only focusing on just the O and the H. Keep in mind that we're trying to find out whether it's polar or nonpolar. A polar covalent bond is where you have a pull. One element takes those 2 electrons and pulls it towards each other. The other one is nonpolar, and that means nonpolar, no pull. This is where everybody plays fair and the electrons stay put right smack in the middle. Now we could answer this question by knowing the analogy snap. We could snap it out, right? If you have a symmetrical bond, that means that that bond is nonpolar. Because if you have the same elements, they can't be pulling one another. They're the same, so they'll have the same attraction. If you have asymmetrical elements, then that would be polar. And if I just look at the bond here, it's oxygen versus hydrogen. So definitely these are 2 different elements, so we would be asymmetrical, which means that this would be a polar bond. So in essence, we can find it out via snapping it out. Maybe I'll just, we'll go over that arrow, but it makes me sad, but just gonna have to be like that. Oh, okay. Also, you could have used your electronegativity values for this as well, but I know some teachers, they won't give you the electronegativity values, so you could use the general trend. You could subtract the electronegativity values to show the difference between them. But, snapping it out and knowing the general trend always works as well. So, there you go. I hope this helped. Thank you so much for viewing the video. Subscribe to the channel, like the video. Thank you so much for your support, and I hope you're doing well out there. If you want more practice problems, you could head on over to our website at glazersguide.com, where you could do more practice problems like this one right here. My brother and I, we've curated all of the questions to help you on those tests and quizzes. So let's get it, right? Get in. But yeah, I hope you're having a great day, and I'll talk to you later, okay? All right. Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.